Good morning guys, I hope you're well. In today's lesson we're going to be learning how to calculate the volume of a pyramid. So the first thing I'm going to do is I'm going to show you a video. What I want you to do is from what you see in the video, can you explain to me in words how you would find the volume of a pyramid? So let me cut to the video. So before I play the video, I'm going to tell you that the shape on the right is a cube and the shape on the left is a square base pyramid. The square base of that pyramid has the same dimensions as the cube, and I'm also going to tell you that, just as you can kind of see anyway, that pyramid has the same height of the cube. Alright, let's watch the video. So from that video, some guy has used some green liquid to show that the volume of 3 pyramids can fit inside a cuboid perfectly with those same dimensions. Using that fact, can you think, how would you work out the volume of a pyramid? Well, taking that sentence that I've just given you, that we've deduced from the video, I could also say that a pyramid is just 1/3 of the volume of a cuboid with those same dimensions, so with the same base and the same height. Can we make a formula from that piece of information I've just given you then? So think about it. How would I find the volume of a cuboid? Well, a pyramid is just 1/3 of the volume of a cuboid. Well, there is a formula that we can use. We can say that the volume of a pyramid is just 1/3 of that base area multiplied by the height. So if we imagined we were finding the volume of a cuboid, well, that's a type of prism, right? So the base area is like my cross section here, and multiplying it by the height, that would give me the volume of a cuboid. But as soon as I divide it by 3, it changes that cuboid into a pyramid, which is what we're looking at today. So, thinking back to your formula sheet from a couple of lessons ago, this is a very important formula that we need to know off by heart, and I would very much like you to record that and keep it somewhere safe, because we're going to be referring to this formula for the rest of the lesson. Okay, so keeping that formula in mind, please can you have a go at questions A, B and C. So pause the video and hit play when you're ready for the solutions. Okay, so taking my pyramid for question A, so I have all the dimensions as you can see in my diagram. So the volume of a pyramid is just 1/3 of a cuboid with the same dimensions. Can you hear that thunder in the background? I'm sorry if it sounds a bit funny, I'm recording this during a thunderstorm. Okay, so 1/3 of the area of the base multiplied by the height. Well, I know the height is 480, and the area of the base, well, the base is a square, so I'll just multiply those two lengths together. Some more thunder. Multiply those two lengths together, and then literally typing this into my calculator, that gives me a huge volume. So it's 91,204,000 cubic feet, and that is my final answer. Alright, let's try question B. Okay, slightly different this time because this time they give us the volume and we're looking for x, which happens to be the height. Okay, so let's write down our formula and plug in everything that we do know. Alright, so we know that the volume of a pyramid is 1/3 of the area of the base multiplied by the height, but we know the volume this time, so instead of volume I'm going to write 50 because we're told that. We know the area of the base because 4 times 3 is 12, but we don't know the height, so we're just calling it x because in my diagram it's x. Okay, so I can tidy this up a bit. Well, 1/3 times by 12 just means 1/3 of 12. So instead of 1/3 of 12, I'm going to call it 4. And then 4 lots of something gives me 50. So dividing both sides by 4, that tells me that something is 12.5. So my height is 12.5 centimeters, and that is my final answer. Alright, so for question C, it tells us the base area. And it tells us that the distance from the base corners to the top of the pyramid is 10 centimeters. So you see where I'm wiggling my cursor? So it's the distance from one of the corners to the top, that is 10. So the height is not 10. And it's asking for the volume of the pyramid. So look at our formula. What do we know? So we know the area of the base, but we don't know the height. So we can't find the volume until we have the height. So let's make a plan, let's make a strategy. Let's get the height. We need the height first. By height, I mean that length that goes from that top vertex of the pyramid vertically down to the base. Okay, there's no obvious way to get that height yet. So what I'm going to do, I'm going to draw an extra line on my diagram that should hopefully help me. So I've added in the dimensions. I know that if the area of the base is 64 and the square root of 64 is 8, so these lengths must be 8. And like we said, this slanted height is 10 centimeters. Okay, where can we go from here? I'm going to tell you, if you work out that diagonal, so that blue dotted line, that's going to be really, really helpful and one step closer for us getting the height. So pause the video if you want to try this for yourself. Okay, so using Pythagoras' theorem, so you need to picture Pythagoras in 3D. Imagine if you were looking at this from a bird's eye view, it would create a right angled triangle. So a squared plus b squared equals c squared. So just working this through, 64 is c squared, 128 is c squared, and now finding the square root of both sides, that tells me that this blue dotted line is approximately 11.31 centimeters. Okay, so that is helpful, but I'll tell you what will be even more helpful if I can halve that. So look at this little animation I'm doing. If I halve this length, so this blue length, and just find this length here, which is now orange, I'm now forming another right angle triangle, which stands straight up. So I've got that 10, half of 11.31. So I'm halving that on my calculator. I'm just rounding it, and that gives me 5.7 centimeters. Do we see I'm now in a really good position to work out the height, because I have a right angle triangle. This time I have the hypotenuse, I have another length in this right angle triangle, so now I can get that height by using Pythagoras one more time. So let's work that through. So be careful here, when I'm using Pythagoras, my longest length is the one to the right of the equal sign, so my longest length has to be on its own. So using Pythagoras' theorem, so rearranging to make h squared the subject, and then square rooting both sides, that tells me that the height of this pyramid is 8.2 centimeters. Okay, let's go back to the question, because now that I have the height, I can now work out the volume, which is what it's asking for. We've done the hard bit, the next bit's easy. I'm just going to substitute. So the volume is a third of the area of the base multiplied by the height. We're told that the area of the base is 64. They give that to us, and we have now worked out the height, which was 8.2 centimeters. Typing in on my calculator, that tells me that the volume of this pyramid is 174.9 centimeter cubed. Done. Okay, so please can you find your classwork attached for you as a PDF on Google Classroom. So work your way through those problems. You don't need to do them in order. It gets more challenging later on in the worksheet. And please let me know if you're stuck or if you notice any typos or anything like that. All right, thank you very much, guys.